This is how to get 24 out of 24 on your internal assessments for IB Chemistry. I'll start with some general guidance and then I will go into an IA which has just been submitted from my lovely students for the November sitting of 2019 and see if we can apply some of the guidance which I'm about to give you here. Okay, so general guidance, where do you actually begin? This is obviously the hardest part, one of the hardest parts. Things that you should not do if you want a high mark. Do not replicate known relationships. Enthalpy of combustion of alcohols can score quite well. It's not going to get you 24. We know that the enthalpy of combustion is going to increase with increasing carbon chain length. Why don't you look at the molecular size, the tessellation, the Debye-Huckel values, extend it, use it, and maybe it could get you the higher marks. Whether the amount of current affects the amount deposited at the cathode, it does, it's in every textbook. If you want the high marks, don't bother. Okay, do not also compare different brands for vitamin C. I see this one quite a lot, so you've got brand A, B, and C. And this one claims to have 50 mgs, and this one's 100 mgs, and this one's 200 mgs. And the student will do an investigation and say, well, this one came out at 75, this came out at 93, and this came out at 362. I used to work in the pharmaceutical industry. There is no way the high school laboratory is going to approach the levels of sophistication required for release of a pharmaceutical to the marketplace, or even a foodstuff to the marketplace. So we don't have HPLC. You might not know what that is. That's the whole point. All we are doing, if we do an analysis on this type of investigation, is showing how wonderful or not we are in comparison with the sophisticated instrumentation which are present in industry. The IB know that we don't have such wonderful levels of sophistication. So do not go down the road of comparing different brands for vitamin C or iron in tablets, for instance. That's not going to get you a good mark. But on the other hand, please don't feel like you have to cure AIDS or heart disease or world poverty. You are a 17, 18-year-old student, and you are a student, and you are expected to produce a report which is commensurate with your level of education. Something which is talked about quite a lot by teachers, the standard higher level split. The IA and the IB as a consequence don't really care about that. The standard and higher level, there is no difference in the descriptors for both levels. I would say as a countenance to that, though, there's no harm if you're an SL student, say that you're an SL student and do some higher level material, because that certainly shows that you are engaged, and that's going to help on personal engagement, is the only caveat I would add to that. What's my credibility? I'm an examiner and a moderator. I wouldn't say I'm the world's best, or not the world's worst, but hopefully this is useful to you. Okay. Do, when you're coming up with your research question, have a research question which will take 10 hours of study. If you're going to do TLC of Smarties and vary the solvents, that probably is going to take about an hour. Bear in mind the people marking your work are chemistry teachers. They know how long it's going to take for you to do your amount of work that you are claiming will take approximately 10 hours of study to achieve. Please do some chemistry. It might seem obvious, but if you're doing a chemistry IA, please make sure there is lots of chemistry that is in there. By chemistry, I mean equations, I mean balanced equations. I mean, if you're looking at the effect of concentration, we would expect a limiting reactant and an excess reactant calculation. Going back to the original one back here, don't feel that you have to cure world poverty. We do kind of expect that you're going to have a method which has been done before, but adapt it, change it to you, and critically reference it. So academic honesty should underpin everything that you do. Okay, we know that you fill a burette, and a million people have filled a burette before you filled the burette. And that sort of thing is not a problem. But if you're just taking a lump of text from a standard method and popping that into your IA and claiming it as yours, that's a serious issue and could actually put you at risk of not getting your diploma. I cannot underline academic honesty enough. So what do you do? Where do you begin? I love the Royal Society of Chemistry. I'm also a member. You don't have to be. That's the thing that teachers do. Look at the Royal Society of Chemistry website. Look at the university outreach programs. The University of Canterbury is a good one. They've got a number of things in there which you can use and adapt and change for your IA. Nuffield Science is a wonderful database of lots and lots of different practicals which you can use in your internal assessments. Google practical chemistry. Guess what comes up? Practical chemistry. Vogel's handbook is wonderful for organic determination and for some quantitative determinations. If you Google that, just put Vogel's.pdf, you'll get about 1,000 different experiments in there. And obviously look at historical IAs. You are teenage students. I'm sure you know how to use Reddit and everything else. Don't copy it. The IB knows that Reddit is there. They know what is on there, and Turnitin.com knows exactly what is on there. And we'll see that in the IA, which I'll be doing with you shortly. Please do take risks and be independent of thought. It used to be a few years ago wonderful when students did novel iodine clock reactions or the BZ reaction, oscillating reactions. Maybe BZ is still useful and fun and certainly engaging in terms of its colour changes. Yeah, I think so. That could be top marking, but don't everyone do it. Please have a clear and focused research question. It can be in two parts if it's focused on the same question. So you could be looking at, like it says here, which I wrote down, molecular size and chain length will be fine. Okay, so use all of these ideas. You guys have the power of Google. You were born clutching an iPad, so you should be able to research better than certainly I can research, but key takeaways are: don't compare brands and don't do standard stuff that's already known if you want top marks. Okay, so personal engagement. Do not say, since I was a little child, I've always wanted to know how, I don't know, current affects rate of deposition of silver in an electrolysis of a silver salt. You didn't. You didn't, okay. You don't have to have, I've said do not, but you don't really, you can if you want, but you don't really need to have a section entitled personal engagement, because that's not how personal engagement is marked. To get 2 out of 2, this is out of 2, set the scientific context. Don't waffle and witter on for paragraphs and paragraphs. You just need one concise paragraph, I would say, and some chemical equations. Don't forget your state symbols. If it's an equilibrium, make sure your sign's correct, because this all goes back to what we're looking for is your personal engagement with the chemistry. Okay, so have a healthy number of scientific references. I struggled. I didn't want to put a number in there. I felt like somebody would want one, so I gave in. Around about 8. You'll see on the IA that I'll share with you shortly, the students probably got at least a dozen different scientific references. So this is not Wikipedia, it's not Yahoo, it's that thing Quora. I don't know how to pronounce that. I think that's pronounced correctly. These are non-scientific references. These are just people shooting the breeze. We want to be new scientists. We want to be chem at Purdue. We want to be a university website. Will be a good place to go for stock chemistry. Please design an original method. If you can design an original method, wow, check you out, brilliant. It's more likely you're going to have an original compound which you found in the cupboard, which you could do, I don't know, colorimetry with, or your school may have purchased a new piece of kit, a polarimeter, for instance. You can look at the mutarotation of fructose. That's also a nice one. You're most likely to be adapting a method and referencing it. Reference. Okay. Original methods will help you to get full score on PE, as will adapted and reference methods. If you correctly interpret your data, the trend was a positive correlation or a negative correlation or an inverse relationship, whatever it was. If you correctly interpret your data, it shows that you care about your IA. That's what we're looking for, that you care about your IA. Were you genuinely curious? When you were doing the experiment, did you stay behind a bit? Did you do some extra stuff? Did you get surprised by the results and go on a different tack? And this is a wonderful thing to put in. So if your original method did not work, and then you said, well, it failed, I researched some more and I tried to adapt it and make it better, and that hopefully worked, that is immediate 2 out of 2 on personal engagements. So don't be shy, don't be worried that it didn't work. That's science, it often doesn't work, but a good scientist will change and explore and then try again. So if that's happened to you, put it in your IA. 2 out of 2 on personal engagement, done. Exploration, do not expect a good mark if you are checking a label claim. I said that 2-3 times already. Do not confirm a known fact. You won't do well on exploration. Don't rely on the textbook alone to get you a good score. Just restating collision theory or restating Le Chatelier's principle or Maxwell-Boltzmann distribution or one of the other dozens and dozens of things you have to do on the IB chemistry alone will not get you a good score. It's fine for the foundation, but then look a bit further. If you're standard, look at higher level stuff. If you're higher level, look at year 1 university stuff. All the material is out there now. There's no excuse for you not getting out there, having a look and showing that you are genuinely interested in your IA. Please do have lots of chemistry in the background, lots of references, lots of places that you've looked at, perhaps even compare different places that you've looked, and if you find a contradiction in the chemistry, which you will, remember Occam's razor, nature of science, then talk about it. What a fantastic thing to put in your exploration. The one that comes to mind is when students look at the average bond enthalpy calculations compared with, say, enthalpy of combustion calculations, or I don't know, bond dissociation calculations, and they all come up with different answers, but it's all for the same reaction. Why not talk about why they are different? That's great exploration. List the variables and how they are controlled and how they affect reliability. You don't have to, and certainly I think it's not required by the IB, but having a table, and I'll show you that in the IA shortly, really, really helps with the scoring on exploration. And reference, just reference all the way through. I'm assuming you know to do repeats. Do repeats. Make sure your method is reproducible, or you could be penalised in this area and in communication. So if your method does not make sense to an intelligent reader, to a chemistry teacher, that's who's going to be moderating you, then you could potentially lose marks in exploration and in communication. Make sure it's reproducible. Safety, ethics, and environmental, students are really good at doing that now, that's nice. So it's judicious quantities, so you use the smallest quantities, the lowest concentrations, the least amount of chemicals, which will minimize the effect on the environment when you are disposing of them. By the same token, if there are no safety, ethical, or environmental issues, say you're doing a database analysis, then don't include them. Just put there are no safety, ethical, or environmental consequences to my internal assessment. That's absolutely fine. Analysis, do not include reams of data logging data, put them in the appendix. Is the appendix marked? No, it is not marked, it is ignored. Do not include qualitative data if it's not relevant. If you do an experiment and there was no sight, there was nothing to see, there was no colour change, there was nothing to smell, there was no gas produced, potentially there was no significant heat generated or taken in, there's no justification for you including spurious or generated or fictitious qualitative data just to hit a box. Just say there were no observations of a qualitative nature in this IA. What about if your data doesn't fit a trend? You could think, oh, that's an epic fail. It's not going to happen. Well, no, it's not. Okay. If you can talk about why it didn't fit the trend, because my resolutions have better handwriting. Why did it not fit the trend? What's the science behind why your trend was completely different to expected or all over the place? If you don't get a trend and you can talk about it in a scientific way, you can still get full marks. Do process your data correctly. And then here are the two massive big kahunas that you need to worry about if you do not want to drop marks. So let me give you an example. if I used a burette, and the range of the burette was 0.00 to 50.00 cm cubed plus or minus 0.05 cm cubed, is that good? Yes, it is. That's perfect. What if I had 29.7 degrees C rise, 30.1 degrees C rise, and 28.4 degrees C rise, and my uncertainty was plus or minus 0.01? Immediately I've lost marks because I've got 2 dp in my uncertainty and 1 dp in my values. The decimal places in your uncertainty must match the decimal places in your value, because you are saying here that you're uncertain in the second decimal place and you're only quoting to the second decimal place. So consistent decimal places is key throughout your IA. From the first number you put down, even in your method, put it in there. Significant figures must be consistent. It used to be that your mean should have 1 less decimal place than the data you put in. That's no longer the case, but you need to be consistent with your decimal places. Numerical errors, calculation errors, inappropriate uncertainties, or inconsistent decimal places. This is massive, I'd say almost number 1, if your research question is good, number 1 area for students losing marks, your grasp of number. Do graph your data. Do not do a bar chart. That's not going to get you top marks. Do a graph with a line on it. Have labels on your axes. Have error bars, which I'll come to in a bit. Have a maximum and a minimum gradient, and talk about if your error bars are outside your maximum minimum gradients, then you have systematic more than you have random errors. I'll come to more of that in a second. Propagate your uncertainties. Should you do standard deviation? Should you do, partial least squares? Should you do any stats at all? Well, yeah, you can do. That's fine. The IB don't really care how you do it, as long as you propagate your uncertainties. It could be your straight percentage uncertainty, as is on this graph here, and just populate it, put your error bars in, double-click the dot in Excel, error bars, and you can put error bars for each one of those. So you've propagated them, so you're looking at the top band now. Discuss your trend. With increasing X, what happened to Y? Or with decreasing X, what happened to Y? What's the relationship between the variables? Is it a scientific relationship? I sincerely hope it isn't. If not, did you change your method and come up with a scientific relationship? In the evaluation, this is the number 1, after this stuff here, the number 1 area, this number 1 thing, the number 1 area where students, they either get tired or bored or go to sleep, but it seems to be the evaluation is one of the more poorest scoring aspects of the IA. How should you open? Reference your research question. What was your research question? What did you expect to happen? Did it surprise you? Was it not what you expected to happen? Does it fit the literature? Does it fit the science? Say whether it did or it didn't. Do not state that you were a very poor scientist and you didn't look at your burette at the right angle, or you weren't looking when you added the material. None of these things will get you marks, okay? Also, don't just say, I would use a more precise pipette or use a more precise thermometer. That's not enough, okay? What you do need to do is compare with a literature value, or if one is not available, which I know happens a lot, put it in a scientific context. Talk about the science. This is all about the chemistry. Do the strengths as well as the weaknesses. Don't say the strength was I got up on time and wore the right shoes and the correct socks and it was a really good day, so my tap on my burette worked great. We don't care, okay? One about the strengths is maybe the method was very well designed. Maybe the repeats showed good consistency. Maybe there was not too much drift or range between consecutive results. If you had anomalies, you talked about them. And wherever you can quantify in relation to your uncertainty. We'll see in the IA, I will share with you in a second, is that the magnitude of the random and the systematic errors should be attempted, and that's with reference to your error bars. Talk about methodological issues. How could you improve in relation to having done the experiments, the original method you set out to do? Okay, if you can talk about how you changed, brilliant, that is awesome. Ensure improvements are precise and relevant. Don't talk about, I don't know, the air conditioning unit or the heating unit, if it had been kept on, or if the door wasn't opened halfway through by little Johnny and a draft wandered in. We don't want to know about that. Okay, we do want to know that you could perhaps have used a bomb calorimeter instead of a spirit burner, or that you could have used an auto titrator, or you could have used a Carl Fisher apparatus. If you don't know what these are, get onto Google, have a research, show your personal engagements. I like tables. I like tables a lot as a teacher and as a moderator. I like to see what was the weakness and what was the improvement. So insufficient range, we're going to exchange the range, that's okay. But if we can have more quantification than we did, or more precise quantification than we did by substituting with a better method, then we should be saying that, and that's what we should see clearly linked to the weakness that's identified, and that's what evaluation is. In communication, appendices, just put loads. We don't want to see every calculation, just an exemplar for each calculation. The rest can go in the appendix. Loads of data from data loggers, we don't want to see that. It should be between 6 and 12 pages. I'd say closer to 12 than it is to 6. And you should have lots of chemistry and lots of good references in your IA. Okay, I hope you found that little section and have a look. Okay, what's nice? Research question. How does the dielectric constants of solvents with varying degrees of polarity, non-polar, polar protic, and polar aprotic affect the rate of hydrolysis of bromoethane via an SN2 mechanism? I like it and I don't like it. I like the fact that it's very descriptive, it's very chemistry focused. It's quite unnecessarily complex. I think, how does the dielectric constant affect the rate of hydrolysis of bromoethane via SN2 would have been a bit more focused, but we'll let the students off for that because it's actually got lots of lovely chemistry in it. Introduction, talking about learning SN2, mechanisms. So showing, it's not going to get the marks for personal engagement as I said, but let's have a look where else we can get the marks for personal engagement. Here we can see the nice background. There's lots of chemistry in here. I can see formulae all the way through. We've got nice referenced, correctly referenced energy diagrams that are in here. So SN1 and SN2 mechanisms, description of the mechanism of attack, which is quite nice, and then we've got some stereochemistry at the bottom. This is all pretty much HL material. This is a HL student, but as I said before, we don't really care about whether they are HL or SL. So where has this student extended beyond the syllabus? Well, I can see that they've researched a lot. I'm already thinking they've got 2 out of 2 on here. Talking about the electron density with the nucleophile, nature of the halogen, leaving groups, probably Lewis acids and bases are somewhere in here as well. So background is appropriate and most irrelevant and adds to the context of the investigation. So all of this is relevant to the research question. They've used ChemGuide and SlideShare, which is all standard stuff, but they're obviously clearly interested in what they are doing and how they are going to achieve it. Now, see what I was saying about the tables? Use the tables. Tables are great. What's the variable? Independent variable. Solvent proticity, we can talk, proticity, 5 different solvents will be used. Description, brilliant. What's the dependent variable? Time taken, awesome. So the dependent variable is not the rate. You can't measure the rate, but you can measure the time. Common error, say what you are measuring for the dependent variable. How will it be controlled? Lovely. Control variables, moles, always have mold, concentration, limiting reactant, excess reagent. And you can see here the student's treatment of number. They've got, now look what they've done, they've got inconsistent, that's CM cubed, that's DM cubed. But will we let them off? Yes, I think so. Because, hang on, that's 20 cm cubed, 0.02 is 20 cm cubed, so they're uncertain about their value, so no, I would penalise them. How many did we get? We got 1, 2, 3, 4, 5, so we had 6 control variables. I think that's a good range. Apparatus, they've included all their stuff that they're using here, so we've got no value on the uncertainty. I would expect to see CM cubed. It's kind of obvious, I'm not going to penalise her for that just yet, but if she keeps doing that, that will penalise her. Methodology, wherever there is a number that will be used in a calculation. So she's missed uncertainty there, and that's got 1, 2, 3 DP, no DP, so that's a penalised now. So you see, it builds up. We'll forgive you a little bit, but if you keep on doing it, then there's less forgiveness available. Silver nitrate, again, she's missed the uncertainties here, so this student's going to get knocked down because they've been inconsistent use of decimal places. Nice method, I believe that this has been taken from somewhere. Why? Because the student would not necessarily know where to know all these things, and that's the dead giveaway. How would they know? So I'll be looking in the bibliography at the end for a good list of where she has taken that from. This is the safety. The students obviously done a fantastic job on the safety. I guess they've used Cleeps, has cards, they have, and copied it out. So it is copied out, but they have done it, so they are personally engaged. Again, personal engagement is throughout. So let's have a look at this data table. Time, no units, no units, no units, no units, no units, no units. So again, just put the units in and that student would have been rewarded. Again, inconsistent decimal places, 2 DP, 1 DP, 2 DP, 1 DP. Note, so the range is good, the presentation is good, but the treatment of number could certainly be improved. Here's the qualitative observations, because she had some. If you don't worry. Right, uncertainties. The IB don't care how you do it, as long as you do it. So this student has chosen to just do total percentage uncertainty, got uncertainty from each one, added it together, and came up with a total. That's fine, that's absolutely good. The rates, the students only chosen the overall rate, overall the data, rather than the initial rate, so that could be extended quite easily. Pretty basic calculation, it's only mentioned, but we would expect some level of complexity with your calculation, your processing of data for the higher marks. This is less good because, look, it's the solvent used rather than the student was looking at the dielectric constant. So this graph does not relate to the research question, and that's what it's all about. What was your research question? That's what you should be researching. Okay. They've now labelled this is dielectric constant, but this is solvent. Time taken, dielectric constant, sorry, is here. This was rate here, now it's solvent here. So I think this is a bit confused. Okay, discussion. Nice long discussion here. She's mentioned the dielectric constants here. That's quite nice. Do we have a table to show you? That's what we're talking about. So in the evaluation, you should be putting what was the error here, what type, systematic or random error, what was the effect, and what's the solution. And that's a really good way of setting it out. Your moderator then doesn't have to go through pages or paragraphs of your lovely writing to find out where the solution is to your identified errors. Further investigation, just put that on the end, it's not going to hurt. Let's have a look at the bibliography. Yes, so she's got 1, 2, 3, 4, 2 pages. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 22 references. Personal engagement, nailed it. Exploration, pretty good. Analysis, some number errors. And we also had the evaluation, which was pretty good. And communication, I think it flowed quite well as a report. So this is a high scoring report, but it's not full marks. So going back to our rubric. So this rubric here, I will try and attach it at the bottom of the video, if that's possible. I've not done that yet. That could be a new thing for me to do. This gives me guidance on how I achieve each criterion and get my full 24 out of 24 on my IA. The IA is worth 20% of your IB.